Hey there, this is Edgar Lindo. Let's talk about offline filter for a hydraulic system. What should be the GPM of an offline filter unit? Let's say that you have a hydraulic system and you want to size an offline filtration unit for your hydraulics. So the way to do it is taking a look at the reservoir. How big, how many gallons does the reservoir hold? So let's say you have a 100-gallon reservoir. What should be a proper offline unit system to put on the reservoir as far as a GPM? Should it be 10 GPM, 20, 40, 30? What should be the right number of offline filtering unit in relation to your hydraulic system? So first time we look at it is the reservoir. So let's say we have 100 gallons reservoir. The idea is to recirculate the hydraulic tank 3 to 4 times per hour. So if you have 100 gallons, what you do is you do 100 times 4. Let's put it the bigger one on 4, and you divide it by 60 minutes. So 60 minutes equals it'll give you 6.6667 GPM. So if you have a 5, 6, 7 GPM unit, that should work good enough to recirculate the reservoir 3 to 4 times an hour. Now, with that, you have the proper size. You have the proper flow to maintain your contaminations levels to a certain level that you need. The other point that to take a look at it is going to be what is the actual goal that you have for the ISO 4406 solid contamination particle count that will be in your system, and that depends on the type of component that you have in your system, and that depends on what type of pump, what type of valves, if you have proportional valves, if you have a piston pump. Some components need a cleaner oil than other ones, and so what you do is you take the most sensitive component and you match the contamination levels of that sensitive component, and that's the contamination level that you should keep on your reservoir. So what goal would that be? That's according to ISO 4406, and each hydraulic component manufacturers recommend a certain contamination level for different components. Most of them, they're all standard. Let's say different manufacturer of piston pumps may have, it's likely they all have the same number for what contamination levels they should use in your piston pumps, in your vane pumps, in your proportional valves. Even though they're different manufacturer, most of them, they all have the same contamination level that you should follow. So you can look it up on the manufacturer record, and there's also standards out there. I should put some apps later, but that's basically the idea. So now a lot of people said, okay, so I have an offline filtering unit. What I'm gonna do, they say, I'm gonna filter one day in this machine, and then I'm gonna move it next day to another machine, and next day to another machine, and next day to another machine. That is not a very good idea. Why not? Because your regular hydraulic system, you have, let's say this one over here is a strainer. Strainer doesn't really filter the oil to lower the contamination levels that you need in the ISO 4406 solid particle count. So, and then you have pressure filters, you have return line filters, and if those filters are not getting the job done to lower your contamination levels, you should put on an offline filtering unit, and you should leave it. You should leave it on the machine at least for as long as the machine is working. Why leave it? Why not move it? Because you want to lower it and you want to maintain the contamination levels. You want to keep them as they are. You don't want to lower the contamination level one day, then move the machine to another location, then move it to another location, and a week later you come back and your system is dirty again. So if it's dirty again, when the machine is running, it creates contamination. Contamination creates more contamination, and the idea is to keep it clean. Otherwise, If you clean it one day and you get it dirtier the rest of the week, then really you're not you're not accomplishing the goal to maintain your machine working properly. For example, a lot of people they look at they put a machine in and they see, for example, directional control valve, the solenoids. The solenoid keeps burning. You have to change solenoids every so often. One reason why a solenoid may be burning in your system after a while is because contamination also accumulates between the spool and the wall of the valve. So when you have contamination getting accumulated, the solenoid, it takes more force for the solenoid to shift the spool. So contamination creates more force, it's more work for the solenoid to move. As it gets older, it loses the force to keep shifting, and you have to change solenoids. So when you install a machine and you keep an ISO level, an ISO 4406 contamination level proper to the hydraulic system, to the right levels, you'll see a lot of less failure in the system. You know, a lot of people get surprised. They say, wow, you know, I put this one, I left it there, and I'm having a lot less failures in the system, a lot less leakage in the system, and it's a lot less headaches. So if you're going to invest in an offline filtration unit, leave it in the machine, don't move it. Another thing with the system is also works independent with the machinery. So your hydraulic system can be running and you can be doing maintenance on the hydraulic unit as well. You can change the filter and you can let the machine run as it runs normally, and you don't have to worry about stopping the machine and then doing maintenance. So that's another advantage of the offline filtering unit. Also, you can start, for example, if it's very dirty, you can start the filtering on the offline unit. You can start it at 20 micron, then lower it at 10, then lower it at 5, up to 3 micron. So you can gradually lower the micron rating on the offline filtering unit. Something that you cannot do on a pressure filter or a return line filter. You don't have the possibility of lowering the micron rating too much because it generates back pressure in the system. So let's say you have a pressure filter that's at 10 micron, and then you put the same filter and you put it at a 5 micron, let's say. It generates back pressure in the main line. So now the system is operating with more pressure in the system, and also the filter is going to get dirtier faster because the pressure differential indicator is already going up. The same thing happens with the offline filtering unit. You have a pressure indicator that if you put a 20 micron versus a 5 micron, sure enough it may get dirtier faster just because of the pressure differential, how it works. However, though, you could put a bigger filter in the offline. You could put a bigger filter in the pressure line as well, but I would say the fastest ways to get the system clean is by recirculating the oil in relation to the size of the reservoir, and you have the control of lowering the micron without worrying about pressure hikes in the system, and you can also do maintenance without stopping the machine. So, and that's the way I usually work with the offline filtering units. So, and that's about it for now. I'll see you later. Bye bye.